Yeah, I think you would. You have 1 minute left.
What? No.
1 minute left.
No.
Quick.
No. So what's the number 2's question mean? State whether this equation is elastic. Oh yes.
20 seconds. 10, 9, 8. And there you go, time up. That's 4 minutes. Let's have a look here. Okay. Oh, you can't see that. Let's zoom in. Can you see? A little too much. Okay. Right, stop. Okay, object A. Object A, mass 2.5, speed 30. Okay. There we go. Object A.
2.5 kilogram and
2.5 kilograms.
30 meters per second.
And the other one?
And it's 4.5. No one.
At rest.
And rest is
This is 0.
Yes.
And then it says, after the collision, A has a speed of 5 in the opposite direction. So then afterwards, this is going at -5, and this is going at V. Okay?
Oh my god.
Did you say +5?
Yes.
Then no marks for you.
Yes.
So, M1, U1 plus M2, U2 equals M1, V1 plus M2, V2. Like that. Okay? Yeah?
Yeah.
That's gone. I'll multiply by 2. So that becomes 150 equals -25 plus 9b. I multiply by 2. Huh?
Yes. So it's not. It's 70.
Oh, that's sorry. What's that? That is.
No. The 150 is wrong.
Is it?
Yes.
But I multiplied by 2.
Oh yes.
So that's right. And then if I multiply this by 2, that's 25, yeah? 9v. Right?
What happened? Why you need to turn to?
I don't want the decimal.
Oh okay.
Because I've no calculator.
Okay.
So I'm being lazy. So this is 175 equals 9v. Yeah?
Yes.
Okay. So v is 175 over 9. Which is 1.9. Sorry, 19.4.
No marks.
No marks for you.
Yeah.
Oh, that was actually part 2.
Yes.
Part 1 is just what's the momentum,
Yes.
which is mv, which is 30 times 2.5, isn't it? Which is 75?
Yes. Oh. I got my
Okay,
mark.
fine. Okay, you got 1 mark. Congratulations. Is it elastic or inelastic? Well, how do we check? You have to look at the kinetic energy. So the kinetic energy before the collision. Well, Ben, what happened to you? You're not usually late. Stomachache? Okay. Kinetic energy before the collisions. A half v squared plus 0. And then the kinetic energy after is a half v squared 25 plus a half, what's the other one, 4.5?
4.5.
A half and then 19.4 squared. Now we have to calculate this, but
Just a thing.
we have to see which is bigger, or rather I should say if they're the same or different.
This is different.
I think they look different.
Yes.
If you calculate it, this is 400, isn't it?
30 square is not 400.
Oh, that's 30.
Yes.
Sorry, that's 900.
Yeah.
Oh, well then, I don't need to calculate it. I can see that this... Well, no, maybe I better calculate to be safe. Summer, can you calculate after? And Khalifa, can you calculate before? Yeah, 878 joules. So do you see it? There's a loss. So if there's a loss in kinetic energy, does that make it elastic or inelastic? Inelastic. So how many marks do you think you got, Summer?
Why?
One. Wonderful.
Yeah.
You had a stomach ache. Right. Okay. So. Right. Next question. How many marks? 5 marks. How much time? 5 minutes. Go.
What's this mean? Define the moment of a
You will
force.
see in 5 minutes. You should see if you can remember. If you read the rest of the question, you might get an idea.
The load being lifted is that means one side it is 10,000
Yeah.
Newton.
Yeah. 1 minute left, but are you finished? Okay. Ben? No idea. Okay. Khalifa? Finished? Okay, so let's just start it now then. You had 1 minute to spare. Right. Summer, did you get the first one?
I think the formula is F equals F distance as a weight.
Yeah, so if you want to give it as a formula, you would say the moment equals the force times the distance.
Yeah.
But in the exam, you must say what the F and the D.
The F is the weight or the
force.
Yes.
Is the force.
Yes.
The force being applied perpendicularly to the end of the lever. So here it is in the picture.
I need to draw a picture.
No, I'm trying to explain it for you. And the D is the distance to
the point.
The pivot point, yeah. Just if you drew a picture and you wrote this and the formula, I'd give you full marks.
So I still need to draw this.
Pictures are great.
Okay.
Yeah, you should draw a picture and a definition if you can. Yeah.
It's the lever or the
lever.
Oh.
Well, I'm not 100% sure of the spelling. I'm not sure if you spell it L-E-V-E-R or L-E-V or no, not or E, no, lever. Be careful. Do you think you got the mark?
I just read the formula. I think I can get 1.
The question is 2 marks. Maybe you can get 1, yeah. But if you get 1 from 2, that's only 50%.
Yeah, I prefer to get 2.
Yes, good. Okay, continue, Ben. Next part, I hope you got it. That's the force, that's the distance. What's the moment? Easy peasy. 10,000 times 10.
100.
Yeah, 10 to the 4 Newton meters. Yeah. If 10 kilonewtons is the maximum load, when D is 30, determine the maximum safe value. Hang on. Oh, they're saying that when it's 10,030 is the safe limit.
Yeah.
What is the D if the weight is 20,000? So they're saying 10,000 times 30, 30 meters or 30 meters?
30 meters.
That's the safe amount.
Yes.
And that should equal what D here if you increase it to 20,000. So this will equal 2 times 10 to the 3 times D. So they cancel. Yeah. D is 15.
No.
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 What?
I think just the one side is 10,000 Newton,
Yeah.
and the other side is 20,000 Newton,
Yeah.
and your distance be short. It's 50.
15?
No. it's not 50. Your distance should be longer.
What?
Oh, yes. But my answer is this.
What did you get for D?
Is 60.
Oh no.
But
No.
where is my wrong? I don't know.
Your mistake. Look,
Yes.
this is D, and this is W1. Okay, and this is the limit.
Oh, I find my wrong.
Your mistake.
Yes, I just the 10,000 Newton equals x 10 30.
Okay.
I thought the x is we need the things.
Okay.
Weight.
So you got 0 here.
Yes.
Again.
Yes. Okay.
Summer. Right. 5 marks, 5 minutes, go.
Is this?
Yeah, kind of. It's the spring. Up, down, up, down, up, down, up, down. You sketch a graph? One minute left. Okay. A mass of 3 kilograms on a spring executes simple harmonic motion. So let's write down the info. M, 3 kilograms. A, 0.025 meters. F, 1.5 hertz. What is the maximum velocity? So you have this formula. You have V equals A omega cos omega t or sine omega t. But that's not really important because you're looking for V max. And V max is just A omega. Because for the maximum, both of these are 1. For what the maximum is. We don't know omega, but that's okay because omega is 2 pi over t. We don't know t. That's okay because t is 1 over f. So it's 0.025 times 2 times pi times 1.5. Right. What is that, please, Khalifa? 0.236 meters per second. Good man. You got that? Good job. These two guys didn't get it. What happened, guys? Forgot. But you didn't get the sketch, though. Okay. You didn't want to give it a guess, at least? In the exam, you should always at least give it a try. So just before I do it, just, have your best guess at what you think it might be.
Wait. Okay.
Yeah? Right. Sketch the kinetic energy against time for 1 full cycle. So, I'll put it here, okay? So this is time. So this is kinetic energy. So if you imagine you pull this down, okay, and you let go, and it goes down, up, down. So what happens is the kinetic energy goes up, down, then up, down. So let me think. 0, bigger, 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 smaller, 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 0.
Yes.
Bigger, 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 smaller, 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 0.
Yes.
So we need to draw 2 quadratics.
Can I draw them like this?
Like what? Straight line?
Yes.
No, it's a curve.
Okay.
Yeah, it must be a curve. They also want to know this number and this number. So, the t is 1 over f, which is 1 over 1.5, which is 0.67, or 667. So, this time is in seconds, that's in joules, and that is, here is 0.667. And we also want the kinetic energy. So the kinetic energy is a half m v squared. Khalifa, do you mind giving me that? Yeah. For 0.835.
I didn't include the square.
Okay. 0. What? Okay, you got that? Right, next. 4 marks, 4 minutes, go.
I think we have 3 or 2 we learn and I forget all of them.
Oh, summer.
I'm trying to. What's the 3 above? So I remember number 3.
I'll help you a little bit, okay?
Okay.
So remember, this is your gas,
Yeah.
and you imagine it's made of little particles.
Yes.
So 3 assumptions about this. I only need 2. One minute left. Did you write anything, Summer? Ben? Khalifa? What did you write?
Yes. Gaseous particles move from one place to another.
No, too general. Anything else?
Particles collide into one another.
Halfway there, but there's something special about the collision.
I wrote 4 actually. Are those is it like temperature increases, pressure decreases? Yeah.
That's more related to the second one. And what's the other thing you wrote? You said you wrote 4 things. Did you?
Yeah, and the opposite of degrees instead of degrees.
No, not quite. Okay, look, let me do it. A couple of assumptions. Number 1, we said the density is small. That was one assumption. Number 2, that there's no potential energy. Number 3, that the collisions are perfectly elastic. There's some assumptions there. No force between particles. There's 4. Remember them?
Did we have formulas?
We did formulas in this lesson, yeah.
Yes, and I remember number 3.
What was number 3?
You said you explained the number why we need.
Ah! Yeah. That's the only thing you remember from that lesson. Right. Next part. Yeah. Explain why, in this model, the pressure increases as the temperature increases. So the reason is, Summer, remember you have the formula PV equals 3 over 2 NKT. That was one formula. And the other formula was, I think, KE equals what was it? 3 over 2 PV? Was that it? Or 2 over 3? Wasn't that the other formula? Yeah? Wasn't it? Anyways, it's if you want, you can explain it using the formulas, but you can explain it in words, okay? As temperature increases, then that means
Pressure.
well, we have to get there slowly. Heat energy increases.
I find my general notes
Good.
in
Physics. If heat energy increases, then that means the kinetic energy increases. Kinetic energy increases means the V increases, the velocity. If the V increases, the mv, which equals the P, increases. Which means the delta P with the wall increases. Which means the force equals delta P over delta T increases. Which means the pressure, which equals the force over the area, increases. Can you? Okay. I probably wrote too much. Do you get the idea? The temperature increases. That means there's more heat energy. That means there's more kinetic energy. That means the particles move faster. That means there's more momentum. That means there's a bigger change in momentum when it collides with the wall. That means the force is bigger because force is delta P over delta T. If the force is bigger, then the pressure is increased because the pressure is force over area. Okay. But if you take these two formulas as well, you could say PV is proportional to T and KE is proportional to PV. Now, if phi is fixed, you can say P is proportional to T, and KE is proportional to P. Therefore, oh, no, I don't even need to say this. I can just use this formula. You can see that pressure and temperature are proportional. If you increase the temperature, you increase the pressure. Okay? Great. Good.
Is R or Q? I remember it's R.
Oh. It depends if this is big N or small n. So, if you remember, Ben, it's PV equals 3 over 2 NKT, or PV equals 3 over 2 NRT. Well, this one here is if you're using a number of particles, and this one here is if you're using number of moles. So you can use either. This is what you use in chemistry, right? Because you use moles. But if you use particles, then you use this formula. Don't worry, you can use this one too. That's fine. Also, this and this, they're both in the formula book, so it doesn't matter which one. Okay. Yeah. Right. No. So what I said was we'll do maths and physics. Okay. So now we will switch to maths. Okay. So we'll look at maths now and open up again the first exam, first year, first version.
Maths for engineering.
Yeah.